Alright, this time we will look at the column bracket. The column bracket is in inches. It has a key seat. Once creating this base, if you round these corners off with your fillet tool, with the sketch fillet tool, you can place the circles. These are raised up. The base thickness is only 0.45. This 0.6 is to the top of this machined boss. So since they stick up 0.15, that would mean that this base thickness is only 0.45. By adding the center plane, or mid-plane, we can take this cylinder and extrude in both directions equally. There is an auxiliary view here. This auxiliary view is necessary for the placement of this cylinder. You will need to form a line of reference to the center line. Overall length and width. The double lines means that this is centered. That is the schematic symbol. So from the center to this edge is 145, which makes the overall width 290. The same thing with the base. Length. From the center of the cylinder over is 220, so an overall length of 220. If you take this calculation, 350 from center to center, and the fact that this radius is 0.45, so 0.45 and 0.45 is 0.9. 440 minus 0.9 is 3.5. Same over here. Okay. There are fillets. We have machined surface symbols. The bottom is machined. Here's the symbol for the machined surface on the bottom. Material is malleable iron, and we have some casting fillets. Let's get to it. This part is in inches. And I would start with the base material. So from the top, by using the origin, you can reference that over and over. Your origin is always consistent. And this one, it really pays off to use the origin. Not only can I create my center rectangle here, I can also create the hole. I don't have to take any measurements, basing this all off the origin as a center. So overall length is, fine, you want to do it this way, 2.2 times 2, and my overall width is 1.45 times 2. The center bore diameter is 1. I want to round these corners off. By sketching a fillet to round this corner off, and actually I want to round these all off, I have a radius of 0.45. By doing so, I now have a center to snap my hole. We can add a constraint to create these hole diameters all being the same. So if I set one diameter, since they all are going to be the same, the diameter is 0.4, instead of going around and dimensioning each one of these individually, I can add a constraint that this hole diameter and this hole and this hole and this one will change drastically. They are all equal in size, and that size is 0.4. Extrude it. Again, the distance to the top of the boss is 0.6. 0.6 minus 0.15 is 0.45 for this base material thickness. Whether I want to add the lugs or the rest of the cylinder, honestly up to you. I'm going to add the boss. I'm going to use my mirror feature as well. By having some axis or line to mirror about, if I take the time to construct one of these, I can now mirror this. Instead of drawing 8 separate circles, I have drawn 2 and 2 lines. Now I can mirror. I want to mirror these two objects, these two circles, let's say on this axis. Why is that diameter different? Oh, I missed one. This one is not set equal. These two are set equal. That's better. All right. Let's back to it. So I mirrored these from side to side. Now I want to take both of these and mirror them to the other side. So I'm going to select all 4 circles, and I am now going to mirror them to the opposing side, and I'm going to raise them all up 0.15. This center cylinder is 225. Keep in mind that I already have a base thickness of 0.45. Just keep that in mind. I'm going to sketch 2 circles. Reference the center. This outside diameter is 160. The fact that I already have 0.45, I am only going to add (2.25) minus 0.45, adding 1.8, I believe is the equation. Yes, it is. So I want to create this cylinder. This will take 2 steps. I'm going to add a plane down the middle. And this is the plane that I now want to work on. I'm going to sketch a circle on this plane. Inside, outside diameter. The origin, I can reference the origin. The distance from this center to here is 0.7. The distance from the bottom edge to the center is 1.5. Inside and outside diameter. I have an inside diameter of 0.6. I have an outside diameter of 1. This overall length is 3.3. And we are going to extrude it in 2 directions symmetrically. Cut it. Do not want to cut it. I want to join it. So now I have to come down and cut through and also cut through here. When I cut down and through, I'm going to cut the key seat in at the same time. First, I'm just going to cut this one. Reference the center. And this is just a cut all the way through. There would be a spot if this was air or liquid was going here. There would be a spot where these are going to mix. There'll be a hole here in the middle, an oblong hole. So I'm going to snap my circle, and I'm going to set my key seat. To keep it from moving, I'm going to sketch a line before I make my center rectangle. All right, so key seat is 0.1 and 0.2. And this is going to get cut all the way through. I'm going to cut the key seat and this at the same time. All the way through. Fillets. By selecting this top surface, I can add the fillet to all of those edges at one time. I'll do this first. So we'll make a fillet here and at each of these bosses and around this edge all at the same time, and our fillet radius is 0.1. So there's all those fillets all in one shot. Fillet again here, 0.1. There's a spot where it would mix. And we have material, which is malleable iron. Should probably set this as a favorite. And machine surfaces. All holes are machined. Oops. Let's go again. Faces. And the key seat is machined. So all these holes are machined. And the bottom is machined. You have a machined surface symbol for the bottom. There you have it, column bracket.